Okay, in this video we're going to do an introduction of functions. So first we'll start off with something called a relation. A relation is a set of ordered pairs, x comma y. Usually it's going to be in set notation, little squiggly set brackets. So everything we're going to look at is a relation. The domain of a relation is going to be the set of all the x values from an xy pairs. The range will be all the y values in the xy pairs. In an xy pair, x is sometimes called the independent variable or the input. The y is called the dependent variable or the output. A function is a relation where each input has exactly one output, y, input x, output y, and so what you're going to look for is no repeating x's. A one-to-one function is a function, so no repeating x's, where each output y has exactly one input x, so no repeating y's also. So we're going to look at a bunch of ordered sets here. Sets of ordered pairs relations will determine if they're functions, and then we'll talk about the domain and the range of each one, and then also see if we can come up with some sort of a formula. Okay, so here's our instructions. So we're going to be given quite a few different relations, and then we're going to find the domain and the range of each. Determine if it's a function. Is it a one-to-one function? And then is there an equation that could describe the relation? So we'll look at our set of ordered pairs: minus 2, minus 2, minus 1, minus 1, 0, 0, 1, 1, 2, 2. The domain is going to be all the x's, so minus 2, minus 1, 0, 1, and 2. The range is going to be the exact same thing, minus 2, minus 1, 0, 1, and 2. This is both a function and it's one-to-one. There's no repeating x's, no repeating y's, so it is both a function and it is also one-to-one. And this is the identity function because both the x and y are identical. What the graph of that looks like is the diagonal line through the origin. So there would be one of our parent graphs, y equals x, and so we're only looking at a couple of sets of or a couple of pairs of those ordered pairs there. Okay, let's see, same instructions. So now we're looking at minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, and 4. Okay, the domain is going to be all the x values, minus 2, minus 1, 0, 1, and 2. The range is going to be all the y values, distinct y values. So you do see we have repetitions of 4 and 1 for the y values. We only list them once in the set notation, so the range is 0, 1, 4. You do have repeating y's, so that's going to make it not a one-to-one function. So this is going to be a function because no x's repeat, but it is not a one-to-one function because we do have y's repeating. So y is repeating, not a one-to-one function. Okay. And the relationship between this is y equals x squared. If you square minus 2 times minus 2 is 4, minus 1 times minus 1 is 0, 0 times 0 is 0, 1 times 1 is 1, and 2 times 2 is 4. So that is the relation. The actual graph is going to be a parabola. So it looks like that. So that's a parabola. So that's one of the parent functions we'll be dealing with in college algebra. Alright, third one we're going to look at is minus 2, minus 8, minus 1, minus 1, 0, 0, 1, 1, 2, and 8. Okay, so domain is just going to be all the x values, minus 2, minus 1, 0, 1, and 2. The range will be minus 8, minus 1, 0, 1, and 8. No repeating x's or y's, so this is going to be a one-to-one function. And then the relationship between the x's and the y's is if we cube the x's, we will get the y. So for example, if we did negative 2 to the third power, that's negative 2 times negative 2 times negative 2. So two of the negatives will offset, and so the resulting answer will be negative. It will be negative 8. So that is the relationship between the x's and the y's, what the graph of this function looks like is some sort of, kind of looks like a snake. Okay, sometimes it's called cubic. Okay. All right, let's look at another one. So here we got 0, 0, 1, 1, 4, 2, 9, 3. There are no repeating x's, there are no repeating y's, so we'll list all the x's for a domain. We'll list all the y's for the range. Because there's no repeating x's or y's, this is going to be a one-to-one function. The relationship between the x and y is if we take the square root of x, we are going to get the y. Okay, so the square root of 9 is 3, the square root of 4 is 2, the square root of 1 is 1, and the square root of 0 is 0. Okay, what the graph looks like, something like this. So this is the square root function. Sometimes we call it the eyebrow because it kind of looks like an eyebrow. Okay, so there's our eyebrow function. Okay, we've got a couple more. So we've got an identity function, we've gotten the square function, the cube function, the square root function, and I think we're going to get a couple more here. Those are our parent functions we'll be dealing with a lot in college algebra. Alright, so what do we got here? We got 4 and minus 2, 1 and minus 1, 0 and 0, 1 and 1, 4 and 2, okay. The domain is going to be 4, 1, 0, and so we do have some repeations in the x's. So if we have repeating x's, that means it's not going to be a function. So we don't even bother to consider if it's a one-to-one function. If you're going to talk about one-to-one, it has to be a function first. So this is not even a function, so we won't even bother with one-to-one. We'll still talk about the range, so it's going to be all the y values. So this is not a function. And so it is, because it's not a function, it will not be one-to-one either. Okay. The relationship between them is if we square the y coordinates, we'll get the x coordinates. And this is going to look like the parabola, but someone knocked it over, so it's going to be shooting out to the right there. So that's what the equation, or that's what the graph of the equation looks like. We won't do a whole lot with it. It is symmetric with the x-axis, so if we're talking about an x-axis symmetry, this is a common example that's used to illustrate x-axis symmetry. All right. Moving along, let's take a look at another one. So -8 and -2, -1, -1, 0, 0, 1, 1, 8 and 2. There are no repeating x's, there are no repeating y's, so this is going to be a one-to-one function. We'll go ahead and list all the x's for the domain, we'll list all the y's for the range. Of course, that's being distinct x's and y's. Well, they're all distinct here, so we're good. Okay, so this is a one-to-one function. Okay, and then the relationship here might be a little trickier, but we remembered that -2 cubed was equal to -8. So if we go on the reverse, if we do the cube root of -8, that's going to get us back to -2. So that is what we got going on here. It's okay to take cube roots of negatives. And so the relationship here is the cube root of x, so y equals the cube root of x. And so this one is also going to look like a snake, but it's going to go kind of the other direction. It's going to go kind of more horizontal, whereas x cubed went vertical. So this is the cube roots. Okay. Number 7, we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. There are no repeating x's, so this is a function, no repeating x's. However, there are repeating y's. The 1 and 2 repeat, so this is not one-to-one. It is a function, but it is not one-to-one. So not one-to-one. Okay, the relationship between these is y equals the absolute value of x. So absolute value means distance from 0, so you can think of the negative numbers, for example, -2. How far away is it from 0? 1, 2. So when we talk about distance, absolute value of -2 is 2. So y equals absolute value of x. This is going to look like a v for the graph. Okay. So we've talked about, what have we talked about? We talked about the identity, we talked about square, we talked about cube root, we talked about square root, we talked about cube roots. Absolute value, so that's 7 functions. We're going to talk about the reciprocal function, I think, and then we got like 1 or 2 other functions that we're going to study in college algebra here. Okay, so last one's going to be like just a ton of numbers here. So nothing big and crazy here. There's just a lot of numbers. And later on when we graph the reciprocal function, we'll want to use a lot of set of ordered pairs. There are no repeating x's, there's no repeating y's, so this is going to be a one-to-one function. And so we can list all the domain and the range. So it's mostly just tedious. Okay, so we picked a lot of points there. And later on we'll do this when we actually do graph what's called the reciprocal function, and as y equals 1 over x. So if you take each one of those x values and plug them into the formula y equals 1 over x for x, you'll get the corresponding y formula, y values. So what the graph of this reciprocal function looks like is something like this. So later on we'll get more in depth on how to graph that. So all these points there are going to help us out, because the more points we have, the more accurate a picture we can make. Okay, so we've looked at finding domain, range, and is it a function, and is it a one-to-one function for sets of ordered pairs. We'll also look at it in terms of graphs. So if we have the graph of a relation, is it a function, what's the domain, what's the range, and then finally we'll look at the formulas of potential functions. Okay. All right, so graphs of relations. The domain is read left to right, start to finish. The range is going to be read bottom to top or low to high, and that's start to finish. We have something called the vertical line test, VLT. The graph of a relation is the graph of a function if any vertical line intersects the graph at most once. Horizontal line test, HLT, the graph of a function, so it already passes the vertical line test, is one-to-one if any horizontal line intersects the graph at most once. So we're going to take a look at a couple of graphs, determine if it's a function, find the domain and the range, and also figure out if it might be one-to-one. Okay, so that's what we're going to do here. Okay, so here we have, it's probably the sine graph, so if you're planning on going on to trigonometry, this is what the sine graph will look like. Anywhere I draw a vertical line, it's going to cross the graph at most once, so this is a function. Okay. However, it is not a one-to-one function, because if I draw a horizontal line across once, twice, 3, it's actually going to be infinitely many times, because the pattern is going to repeat. But if it intersects more than once, not a one-to-one function. Okay. But it is not one-to-one. Okay. We've drawn the arrows to indicate that it's going to continue. So it's going to go all the way off to minus infinity. So that is the minus infinity to infinity is the domain of this graph. The range, we're going to make the assumption that this keeps doing the pattern. Okay. And so it actually gets down to -1. It might be the artist's fault that it doesn't look quite like that, but it does. And the highest it gets is 1. Okay. So it is actually hitting -1 and 1. So how we say that it actually touches -1 and 1 is put a little bracket. So the lowest it gets is -1, and the highest it gets is +1. Okay. Okay. Now let's look at another one. So there it is, and it's. I'm going to just say that the pattern does not repeat here, so it's gonna. This is just going to keep going down forever and going up like that forever. Okay, so they're going to keep going on forever. It is not a function because we can draw a vertical line like this, and it crosses once, twice, 3 times. So any more than once means it's not a function. So it will certainly not be a one-to-one function because it is not a function. So not a function, and we'll go ahead and be redundant here and say it's not a one-to-one function. Okay. It is going to go on forever this way, so the farthest to the left it gets is minus infinity. likewise, it's going to go off forever to positive infinity. And same argument for the range. The lowest it gets is minus infinity, and then it will eventually get to positive infinity. Okay. All right, let's look at a couple more. Oops. So we're going to do parabola. I'm going to try to do the parabola. All right, let's try again. Okay, so now we're going to do the parabola. Here's x squared. It does pass the vertical line test. However, a horizontal line can be drawn to cross it more than one. So it's not a one-to-one function. It is a function, though. Okay. We can talk about the domain and the range. Those two branches are going to eventually go all the way off to minus infinity. So the domain is going to be negative infinity to infinity. Okay, so this is going to eventually go off this way and also to the other direction. Okay. Sorry about that. Minus infinity, infinity. Okay. And the range is low to high. So looks like I'm making an error as I wrote this up. Okay, so the lowest it gets is 0, and it actually touches there. And so because it touches, we'll go ahead and put a bracket there. So this is a function. It is not one-to-one. The domain is everything, negative infinity to infinity, and the range is 0 to infinity. Okay. Number 12, we're going to look at the eyebrow, the square root. It passes the vertical line test, so it is a function. It will also pass the horizontal line test, so it is a one-to-one function. It starts at 0, including 0, and goes off to infinity for both the domain and the range. Oops. Let's see if we can go back here. Sorry about that. There we go. So it starts at 0 for the domain and goes off forever. So 0 to infinity. Likewise for the range. 0 to infinity. My goodness, I'm just hitting all the buttons here. Okay, there we go. So off to infinity from 0 to infinity for that range. Okay. Alright, so next thing we're going to look at is the equations, and we're going to determine if a function, well, it's not necessarily a function, but if a graph, I can't talk today, if an equation is a function. So determine if the equations represent a function. An equation is a function if you don't have an absolute value of y, plus and minus on an expression of x, a y squared, a y to the fourth, or y to the n. That's an even power. Odd powers of y are okay. So basically for this, if I see any of those things, absolute value of y, plus and minus on an expression of x, a y squared or y to the fourth is probably all you're going to see. If you see any of those, then it's not going to be a function. Now there's certainly other possibilities, but for college algebra, that's pretty much what we need to look for. So if I want to get x equals y squared, that has a y squared right off the bat, and so that is not going to be a function. Okay, and what we could check to show that is both 1, 1 and negative 1, 1 satisfy this relationship here. No, that point is not correct. 1 and minus 1. So if x is 1, you have 1 is equal to 1 squared. 1 equals 1, so that's true. And then 1 equals minus 1 squared, so 1 is equal to 1. So both those points are on the graph because they satisfy the equation, and you see that you do have repeating x's, so that's going to be not a function. So here I'm just overwriting over there, and so it's going to be the sideways parabola. That's what we got going on there. If we look at x equals y to the third power, that is a function. It doesn't have any problems. Y to an even power is okay. That is the same thing as the cube root of x is equal to y. If you take the cube root of both sides, the cube and the cube root will cancel each other out. No plus or minus with cube root. That's only with square roots and even roots. And we did draw a sketch of the graph. It was kind of that snake-looking thing there, and so that passes the vertical line test. So what about y equals 2 over x plus 3. That's a function. I don't see any of the absolute value of y, the plus or minus on the x, a y squared, a y to the fourth. It's a function. Same thing with a polynomial. Y equals x cubed minus x squared plus 5x plus 2. No absolute value y, no plus or minus on an expression of x, no y squared, no y to the fourth, so that's going to be a function there. Okay. All right, the last thing we're going to take a look at is evaluating functions. So it's going to be plugging in values for x, so it's something you've done before. Maybe not with a function notation though. So when we say y equals f of x, that communicates that y is a function of x right off the bat. As an ordered pair, an xy pair would look like x comma f of x. And the syntax here, we need another parentheses there. Okay. To evaluate a function, we're going to replace all the x's with parentheses, and then we'll fill in the number that x is equal to. Okay. So whatever the given value of x is, okay? Okay, and then follow the order of operations when you're all done. All right, so we're given, what are we given? F of x is equal to negative 2x squared plus 5x plus 6. And first thing we're going to do is we're going to find f of 0. So it's going to be negative 2 times 0 squared plus 5 times 0 plus 6. So stick in those zeros. So when we multiply by 0, those cancel out. So all we're left with is 6, which kind of looks like 16. So let's make sure the box goes all the way around. Okay. How about f of 2? It's going to be negative 2 times 2 squared plus 5 times 2. Plus 6, so it'll be negative 2 times 4 plus 10 plus 6, negative 8 plus 16, that's going to be 8. Okay, f of happy face is going to be negative 2 times happy face squared. So does that make it a square face? I don't know. So negative 2 happy face squared, whatever that means, plus 5 happy faces, and plus 6. And finally, we'll do f of negative t, which will be negative t squared, plus 5 times negative t, and plus 6. So negative t squared will make it a positive t squared, but because you had a negative on the outside, you're still going to have a negative there, so negative 2t squared, and then minus 5t, and then plus 6. Okay, that's it there. So I think we got 2 more examples of doing a little bit of evaluating with functions, and then we'll do a difference quotient. Okay. So f of x is equal to 5. So f of 0 is equal to 5. And f of 2 is equal to 5. And f of happy face is equal to 5, and f of negative t is equal to 5. So because our function says f of x equals 5, that means y equals 5. Doesn't matter what x is. There's no place to plug in the x. So it doesn't matter what x is. Y will be 5 every time fx stands for y. Okay. The last thing we're looking at is something called the difference quotient, and maybe we'll throw in an extra example here. We're going to do the difference quotient with number 18 here. So let's go ahead and add in another part. Let's see, f of e. We'll say f of a is equal to 5. Letter f of a plus h. Well, doesn't matter what we're feeding it. It's still 5. Okay. Difference quotient is f of a plus h minus f of a all over h, and it's something we use in pre-cal and calculus. It's related to the slope. We won't get too much into it in this video. Maybe in another video we'll get into the difference quotient a little bit more. But if we want to find the difference quotient, so if we want to find the difference quotient, I need to find, first I need to be able to spell quotient, and then we'll go ahead and find it. So f of a plus h is 5. F of a is 5, so 5 minus 5 over h. It's going to be 0 over h, so that's going to be 0. The difference quotient talks about the slope of what's called a secant line. Now f of x equals 5, that's just a horizontal line. So if I take any 2 points on the graph here, the secant line is going to connect them. Okay, so it is exactly on the graph. The slope of a horizontal line is 0. So we're going to go ahead and look at a quadratic, and we're going to find the difference quotient of. So we're going to look at f of x equals 2x squared minus 3x and plus 2. So first thing we're going to do is we're going to find f of a. So we're just going to plug in a for the x. And then the fun part is to find f of a plus h, because we're going to have to FOIL and do a bunch of distributive property. So it's a little bit of a mess, but it's not too hard. So 2 times the quantity a plus h squared minus 3a plus h plus 2. Okay, so we got to be careful. So 2, and then it's a plus h times a plus h. That's what the a plus h squared means. Okay, minus 3a minus 3h, and then plus 2. So it'll be 2 times a squared. And then as we're foiling this, a times h will be ah or ah. And then h times a will be ha. Okay, so aha, really, we can go ahead and commute the a and h, so that'd be ah plus ah, which will be 2 ah there. So it'll be a squared plus 2ah. Plus h squared, so 2ah plus h squared minus 3a minus 3h plus 2. Distribute the 2, so 2a squared plus 4ah, and then that right there should be a 2h squared. 2h squared minus 3a minus 3h plus 2. And finally, we'll put it all together in the difference quotient. So it'll be f of a plus h minus f of a all over h. So we already found f of a plus h is that mess, 2a squared plus 4ah plus 2h squared minus 3a minus 3h plus 2. And then the f of a was 2a squared minus 3a and plus 2. Okay, so it'll be 2a squared plus 4ah plus 2h squared minus 3a minus 3h plus 2 minus 2a squared plus 3a and minus 2 after we distribute the minus sign all over h. And then we get to play the canceling game, so 2a squareds cancel, and minus 3a and 3a cancel, positive 2 and negative 2 cancel. So what we have left is 4ah plus 2h squared minus 3h all over h. GCF is an h, so we'll factor an h out of the top. And then we can cancel the like factors of h on the top and the bottom. And finally we have 4a plus 2h minus 3. Okay, and that's going to be used in pre-cal and then also in calculus. So for those of you going on to calculus, you'll see this difference quotient. And in calculus, the hardest part is the algebra. So what we have just done is the algebra. And so that's going to give us a tangent slope generating function. So the parabola, this is some sort of parabola. So depending on where you're at, the tangent line is going to be different at different locations. Sometimes it's going to be steeper than other places. Just depends on where you're at. Okay. All right. So that is it for this video. It's a little bit of a longer one.